guys. Let's make sure this is recording. There we go. So let's just talk about the second derivative test. So just for purposes to move through the videos a little bit faster, f prime they give us. So watch out for that. Make sure you understand that they give us f prime. And we're going to use the second derivative test. So you can do it whatever way you want. I just went straight down here. So if they give us f prime here, I can factor it out, set each piece equal to 0, and I get some critical points at 0 and 3. So let's figure out what they are. So if I plug in -1 on this side, I get a negative. That means my graph is decreasing for x less than 0. I also get my graph is decreasing from 0 to 3. That's an interval here. And then I also know that with x greater than 3, my graph is increasing because it's positive on this side. So a couple of things are happening here. I go from a positive to a negative. So we know that this is a local minimum or a relative minimum. I go from a negative to a negative, so something's happening at this point. So I'm looking for an inflection point here. So it's still going down, so it could look something like that. More than likely, it's going down, it's decreasing the slope, but it's changing somehow right here, even though it's still negative. Because when I get to 3, I need to curve up, because that's x equals 3. This is at x equals 0. So something's going on right in here. And I'm going to make sure that's on the video, guys, because if not, I'll redraw it for you. Pretty close. Yeah, you're close enough. So I'll just do this. There we go. So this is telling me that the graph looks something like this. It's decreasing less than 0. Something happens at 0 because it goes from a negative slope to a negative slope, so we don't have a max or min there. But at the same time, it's increasing over here, so I know I've got a minimum here. And these are going to go on forever. That's why it's just a local or a relative. Now, so how do I figure out what's going on here? At that point, I have to check my second derivative test, which tells me where the inflection points are and where it's concave up or concave down. So it's cup for concave up or concave down. So look, concave up, concave up, concave up. All right, so take the second derivative. So we take the derivative of this one, and we go 3 times 4 is 12. Oh, this should be x squared. I just realized that. That should be x squared. 12x squared minus 24x, and then I get a 12x out front and an x minus 2. So my critical points for my second derivative are x and 2. So I take x and 2, put on my sign chart, test a number to the left, I get a positive number, test a number in between, I get a negative number, and then test a number to the right of 2, and I get a positive number. So that tells me with the second derivative, that tells me since it's positive, positive's up, let's think, positive, it's a concave up piece, right? And then it is a concave down piece at 2, and then until 2, and then it's concave up. So let's write this out. So when we look at x equals 0, we're looking at this here. We have I might have drawn it wrong, so we can just kind of leave that there like this. So if I'm looking at this here, I have concave up from, it is concave. Is that going to be negative? Negative 2. Yeah, it's still. Something doesn't feel right about this one. That's at x equals 2, that at x equals 2. So if I put in -1, we get -1. That's a positive. If I put in 1, I get a negative. If I put in -2, I get -24. Positive, yeah, so that's still right. Okay, so it's concave up from x, it's It's concave up for x is less than 0. It's concave down between 2 here. And then after 2, it is concave up, right? So we have a concave up piece here. We have a concave down piece at 2. And my maximum or my minimum is at 3. So what does this thing look like here? So what are we looking at? I don't think they want us to draw it. Let me double check it. So, oh, they don't want us to draw it, which is fine. So something is a little wild here, but that still works out, so we're okay. We're still okay there, guys. Because it can look a little different. Let's just kind of see if we can draw this thing. So let's put it on a graph. I don't know if it's going to work or not. So let's put all our critical values here. So we got x equals 3, right? We got x equals 2. We got x equals 0. All right, so at x equals 0, it is decreasing and it's concave up. So at x equals 0, it's decreasing and it's concave up. I'm okay with that. And then at x equals 2, from 0 to 2, from 0 to 2, it's decreasing because it's in this interval, and it's concave down. So let's just put a point here. It's like this. There we go. And then from 2 to 3, it's concave up, but it's decreasing because 2 is right here, right? So it's still decreasing, but it's concave up. And then from 3 on, it's concave up. So here's my minimum. Here's one of my inflection points. Here's another inflection point. So this covers all of it. So let's kind of walk through it. From anything less than 0, my graph is decreasing and it's concave up. It's got a cup. There it is, decreasing to 0. And then from 0 to 2, it's concave down, so it's going to have a curve down. But from 0 to 2, it's still got to keep decreasing. So now I get a curve a little differently here. So now we are still decreasing. And I'm concave down now. And then I'm looking at this here, my next inflection point, which is at 2. It's still decreasing according to the first derivative test, but then it's got to be concave up according to the second derivative test. So now I've got a decrease with a concave up, and then from 3 on, it's concave up, 3 on, it's positive. So now I've got an increase and concave up like a cup. So that's all the information you can pull from the first and second derivatives. We're going to turn this into particle motion soon, where it comes to these mean acceleration and velocity and different things like that. So that's the second derivative test. There you go.